Hello everybody. My name is Jussa Klapuri. I'm working as a data architect at Brightly. Today I'm going to talk about industrial data management in Databricks. But first, some information about our company. So we were founded roughly 4 years ago. We have now 90 employees, and we work in different sectors. Many of our projects happen to involve IoT, and also many of our projects, we use Databricks as the data processing solution. So we have our demo over there. You should go check it out. Basically, we have factory I/O simulation, and then at the end of the pipeline, we have a Power BI dashboard. So I'm going to explain a bit about what happens at the end of pipeline. So the data coming in is OPC UA data. I probably know less about OPC UA than anybody sitting here today, because this is a very new thing for me. My background is strictly in data engineering and data science. So today's topic is I'm going to talk a bit about the challenges in IoT data, and then how you can solve those problems using Databricks, and how you can achieve near real-time processing for large data sets. So I'm going to talk about some building blocks, a medallion architecture, and then some newer concepts such as delta live tables. I'm not going to talk about machine learning or AI applications, but I should mention that if you want to do some kind of AI on top of very large data sets of recent data, you need to have a very good data platform, and you need to have it already in gold standard format. So that's just this important step towards it. So today, the analytics and AI for IoT data is complicated. So companies have lots of data from different sources, IoT data, big data, and then you have different data products that you need to do and provide, like BI and analytics, AI apps, real-time apps, and so on. So what happens in the middle? Currently, the case may be that you have all kinds of different products for different purposes. For example, you have time series storage for telemetry data, or you have event processing engines for streaming IoT data, data lakes for files such as, or unstructured data such as files, videos, and images. And you have data warehouses for enterprise data. In addition, you have different machine learning and data science platforms. So the challenge is that if the data is siloed up into different applications, it is duplicated. It costs more to duplicate data. It's more difficult to scale up. And it may be locked in proprietary formats that require specialized skills. So any kind of apps or products using different data sources, it may be difficult and costly to create. And also managing security and governance becomes more complex. So what me and my colleagues have done in several projects is that we implement Databricks solutions. So it's basically like an open data lake to solve these problems. So you have the same needs and you need to have the same products, but you store everything in this data lake using Databricks. So it supports incremental ingest, data warehousing, and BI, ETL and real-time processing, and also it has great machine learning libraries. So basically, because it's open inside the company, you can more easily combine different tables, different kind of data sets to be able to do what you need to do with the data. And how this is achieved is that the engine of Databricks is Spark. So it is nowadays the de facto like standard unified analytics engine for big data processing. It was actually created by the founders of Databricks some 10 years ago. And what it does is that if you use Spark by itself, it can be time-consuming to configure and set it up. And basically what Databricks offers is to make Spark much more easier and friendly to use. So you separate compute and storage, and then you create different applications or queries, and then you assign a cluster to perform these queries. And you can scale the cluster however big you want, and usually it can scale up quite well, depending on the task at hand. So if Spark is the computation, then Delta Lake is the storage. So the key features are basically ACID transactions, so it's similar to ordinary databases. And scalable metadata, so it supports very large tables, like petabyte scale, and time travel. So if you have a table, then you can query older versions of it without actually reverting back to them. And when I talk about table, I basically mean like a table that you can interact with as a SQL table, because you can query it using Python or SQL language. But it's not a database in the same sense as like MySQL database or some such. It's also open source, and it unifies batch and streaming, exactly one semantics, ingestion, and schema evolution is also, there are good features to handle this. Also, it supports audit history and DML operations, so basically merge, update, and delete on datasets. So if Delta Lake is the storage for all your raw data, raw files, it's also the storage for Delta tables. So these are basically the tables. If you have any kind of data pipeline, the intermediate tables and the gold tables, you basically use this Delta table format. So it's less of a black box than in basic SQL database. Basically, it's a set of Parquet files plus the metadata. So here's just an example that if you have a row-oriented data on disk, such as CSV file, it can be very slow to compute aggregates, and it takes a lot of storage space. But when you store it column-oriented aggregates and different compression algorithms, it makes the files much smaller, and they are very, very fast to read. And also Parquet format supports nested data, such as structs, maps, and arrays. And then typically, when you implement any kind of data pipeline with Databricks, you talk about medallion architecture. So you divide it into different layers, so bronze, silver, and gold. So bronze layer means basically you have the raw data. So you create a Delta table of raw data. You don't modify it much at all. Maybe if you have a like OPC UA JSON raw data, you would try to divide it to different column types if it's possible. But it's still raw data. And then on the silver step, it's more refined and more cleaned version of the data. You perform data deduplication if needed. You also then can enrich the tables with additional dimensional data if you need to. And then when you move to gold, the gold layer is actually like the gold standard, so that this can be provided to data analysts, data scientists, or just apps like Power BI. So you can create like aggregate tables and any kind of gold standard tables. And typically you you do it as a streaming job, so that you can incrementally ingest new data when you run the stream. Or you actually have a cluster, this kind of Spark cluster that is constantly consuming new data and flowing the data through this whole pipeline. And then Delta Live tables. So this is like an abstraction built on top of Delta tables. This is like roughly 2 years old. So what you can do is you can define, in this example, there's some SQL code. You create a raw data table by selecting some actual raw data files, in this case, JSON. Then you create a second, like a, let's say, silver layer called clean data, and you read directly from this raw data table. So when you define these two calls, then this Delta Live tables or DLT pipeline, it automatically handles the dependencies between the tables. It creates like the directed acyclic graph for the data to flow through, so it figures out what tables need to be filled first, how does the data flow after that. And it also handles then, if you need it to configure for production jobs, the retry logic, for example, that when you have it running, if it crashes for any reason, you automatically create a new cluster and continue where it crashed. And also you can always configure the auto-scaling clusters. So if you start having much more data coming in, you can scale up the cluster automatically and process it and then downscale it fast. So you want to downscale clusters simply because it saves in costs. And also it has some basic data quality features, which I have a separate slide on. Here's an example how it might look like. You have raw data in some cloud storage or message queues. You would create like customers and orders table. You combine them in silver layer, and then you calculate aggregates on daily level for the gold table. And when you define it through this DLT, what you can do is you can schedule the pipeline to retrieve the latest data at certain intervals, hourly or daily. Similar to batch, basically, but with automatically incremental ingest. So you only retrieve the new raw data. So this raw data could be like JSON files provided by OPC UA, or any kind of IoT data, really, or other type of data as well. But you can also configure this same pipeline to run as a stream. So you leave a cluster running, and whenever there's new raw data coming into the landing zone, then it automatically loads it to bronze layer. And then silver layer notices that there's new data on bronze table, so it flows to silver and gold and so on, and it's a constant loop when you leave it running. So you can either run it batch or stream very easily. And here's an example of expectations. So you can have simple data quality measures by defining what is valid data. So in this case, if you can see from there, here's some condition like valid trip distance, valid passenger count, and so on. So you would define these expectations as what is valid data and what is non-valid data. And then when you can define what happens when invalid data arrives. So you can just define it that ignore it and leave it as it is, but you log the error. Or you can drop it from the table completely. Or you can also just fail the pipeline so that it's some critical bug that you need to fix by hand. And also you can configure it so that you can put quarantine or the invalid data into quarantine table automatically. And it also supports, basically it creates tables of this data quality, separate tables. So you can then create visualizations on this invalid data. and data quality percentages and so on. So this is back to beginning now. So this is basically the simplified pipeline in our IoT demo. And basically when you implement this, when you already bring the data to cloud and you implement this processing step with Databricks, for example, with Delta Live tables, then you can achieve near real-time analytics, even with very large data sets. And by near real time, I'm saying maybe under a minute or a couple of minutes. Then this whole large data sets, they are queryable with Python or SQL, and you can use it for many different purposes or machine learning quite easily whenever all the relevant data is in the same source in this Databricks lakehouse. So in our demo, then we display it in Power BI desktop or this custom visualization. But yeah, this was basically my presentation. So I want to thank you, and if you have any questions, feel free to ask, and also you can ask later on in our stand. So thank you.
Thank you.